We've answered part A and B. We are now going on with the question to part C. Part C reads, the following 4-year step-up callable note pays 4.25% interest for 2 years and then 7.5% interest for the next 2 years. The note is callable at par at the end of the year. At the end of year 2 and year 3, the note has a par value of the first 100 shillings. It is assumed that interest rate volatility is 10%. So we have the binomial tree there. We can see the first row is today, year 1, year 2, year 3, and year 4. Then we are given the rates. The rates are given within we have the discounting rates. Then we have the details concerning this step-up callable note. Required Roman 1, calculate the value of step-up option free bond, 4 marks. Roman 2, the value of step-up callable bond, 4 marks. Roman 3, the value of the embedded call option. Embedded call option. So that is the question. So we have the binomial tree. This binomial tree that I have drawn on the board is the same one that is on the question paper. I've drawn it here so that I can demonstrate how to calculate the value of step-up option free bond. This is exactly what was provided within the question. And we read the first sentence that the following 4-year step-up callable note pays 4.25% interest for 2 years. All right. So here you have 4.25 year 1. This should be year 1. Year 1, 4.2%. Year 2, 4.2%. These are nodes. Then we read that, and then 7.5% interest for the next 2 years. For the next 2 years. For the next 2 years. So we have for the next 2 years 7.5. So this is 7.5. 7.5 for the next 2 years. That is from year 3. So we have year 1, 4.25 is 4.25%. But within the binomial tree, it's not shown as a percentage. It's given in form of value. It's 4.5 shillings. It's 4.25 shillings. The coupon, the par value, candidates, the par value is 100 shillings. When converted into percentage, this interest will be 4.25% times 100. So 4.25% is equivalent to 4.25 over 100 times 100. So this gives us 4.25 shillings. That's why here we have 4.25 shillings, 2.25 shillings, 2.25 shillings, 2.25 shillings, 4.25 shillings for the first 2 years. Then for the next 2 years, the interest is 7.5%. For the next 2 years, the interest is 7.5. So we have here 7.5. Then we also have 7.5 fourth year. When converted into shillings, 7.5 will be equal to 7.5 over 100 times the par value. That's why here candidates we have 7.5 shillings, 7.5 shillings year 3 and year 4. That explains why the 4.25 is not shown as a percentage within the binomial tree. Then within this binomial tree, we have the percentages. These percentages, the 5.42899. This is what we'll use as a discounting factor when calculating the value of the bond. We'll be discounting using these factors. These are discounting factors. So the first requirement is to calculate the value of step-up option free bond. The value of step-up option free bond. Now, what is a step-up option free bond? Step-up option free bond. Before we calculate the value, I want you to understand the meaning, first of all, of the step-up option free bond. Step-up option free bond. Step-up option free bond. Now, a step-up option free bond refers to a type of a bond that includes a feature where the coupon rate increases. Where the coupon rate increases. The coupon rate increases. This increasing nature of the coupon rate is what we are calling step up. It is the coupon rate that is stepping up, that is increasing. And we read that the first two years it will be 4.25%. Then the next 2 years, 7.25%. That is stepping up. The coupon rate is increasing from 4.25% to 7.5%. It is a type of a fixed income security that offers an initial interest rate that increases at predetermined intervals throughout the life of the bond. And such a feature, candidates, is designed to make a bond more attractive or admirable to investors, especially in an environment where interest rates are expected to increase over the life of the bond. You understand? That's the meaning of step. So I've said it is a type of a bond. It is a type of a bond that offers an initial interest rate that increases at predetermined. And I've said it includes a feature where the coupon rate increases at predetermined rate. You understand? That is the meaning. Now we are now going to calculate the value of step-up option free bond using this binomial tree. And candidates, a binomial tree in the context of finance is a graphical tool that is used to model the possible price movements of an asset like a bond. It's particularly useful for valuing options, which are contracts that give the holder the right but not the obligation to buy or sell an asset at a certain price by a certain time. So this is a binomial tree, and you can see this tree has branches. Beginning here, the tree has branches. You can see the branches? the tree has branches. These are branches that I've shown with the arrow. Then these boxes are called nodes. Nodes. And each branch is assigned a probability. Each branch is assigned a probability. And the probability represents the likelihood of the price moving up or down from the previous node. You understand? And the probabilities are usually assumed to be equal. The probabilities here are assumed to be equal. That is 50-50. The probability of 0.5, 0.5, 0.5. Each branch is assigned a probability which represents the likelihood of the price moving up or down from the previous node. And the probabilities I've said are assumed to be equal, 50-50, for the sake of simplicity. Are you learning something? Yes, you are. It's important for you to have that because we are going to use these probabilities in calculating the value of the step-up option free bond. And if I was to take you back to the question, we read that the callable notes pays 4.5% interest for 2 years, and then 7.5% interest for the next 2 years. The note is callable at par at the end of year 2 and year 3. The note has a par value of 100 shillings. It is assumed that interest rate volatility is 10%. So the par value of this note is 100. The par value of this note is 100. You understand? So we are going to perform a back pass. We'll be computing the value of the bond moving from the right to the left. Moving from the right to the left. We start with this node and this other node. You can see the 100 is the principal. 7.5 shillings is the interest. So these two nodes are preceded by these two branches, right? These two nodes are preceded by this node. So we are going to get the present value of these two cash flows using 9.1987% as a discounting rate. So I repeat, we're going to add 100, this 100 plus 7.5 times 0.5 plus 100 plus 7.5 times 0.5. Then we discount using 9.1987% as a discounting rate. The present value, we write it in this node. This is what I mean. Let me demonstrate. The first node there, we'll take 0.5 times 100 plus 7.5, this times that, plus this times that. This plus 0.5 times 100 plus 7.5. We get the sum. These are two probabilities which must add to 100. 0.5 plus 0.5 is equal to 1. This we are going to discount 9.1987% converted into decimal. It will be 0.09 0.091987. That is the percentage. But remember, we need to add 1. It should be 1 plus R. This is the R. 1 plus R. So we are going to get that calculation. So the answer at this note is 98.444 shillings. We'll carry out the same operation with these two notes. We add these two notes, we discount using this discounting rate, then we write. So we're going to have 0.5 into 100 plus 7.5 plus 0.5 into 100 plus 7.5. Divide by 1 plus 0.075 312. It's equal to 99.9710. Moving on to this node, we get this total here, then discount. That is going to be 0.5 into 100 plus 7.5 plus 0.5 into 100 plus 7.5 divide by 1.06166. Answer here is 101.2565. Next, add these two, discount. We are at this point. At this point, we add these two. The rate is 5.0, so it will be 1.05, 1.050483, one or 2.3339. So we've done that operation at year 3. So these are the values, the value of the present value of the sum of the par value and the interest. So this is at year 3. These are the values at year 3. We'll carry out the same operation by adding 0.5 times 7.5 plus 98.444 plus 0.5 times 99.9710. This is what I mean. We are going to combine these two nodes to get the present value at year 2. That would be equal to 0.5 into 98.444 plus 7.5. 7.5 is the interest, plus 0.5 into 99.9710 plus 7.5. We are going to divide all this by this factor, right? Divide by this factor. That will be 1.0700053. That will be equal to this. I should not write here, but I should write these two should be equal to 99.7219. Are you following? Yes, you are. It's very simple. Back pass. We are now going to sum these two nodes. The present value, we write it under this node, and that will be equal to 0.5 into 99.9710 plus 7.5 plus 0.5 into 101. 101 is the discounted figure from year 5, 25, 65 plus 7.5. We are going to divide all that. We're going to divide all that by this factor. That is the discounting rate. It should be 1.057354. $102.2493. Moving on well. We move on to these two nodes. These two will be 101.25 times 0.5 plus that, then 102.339 plus 7.5 times that. So let's begin with this. 0.5 into 101.2565 plus 7.5 plus 0.5 into 102.339 plus 7.5. Divide by 1.046958. The total, will write it here. Yes. 104. 104.3931. We are through with year 2. We move back to year 1. Year 1, we begin here with these two nodes. We're going to take the now you can see candidates in year 2. The interest is no longer 7.5 but 4.25. 4.25. So under this one, we change from 7.5 to 4.25. 4.25, beginning with these two. We're going to have 0.5 into 99.7219 plus 4.25 plus 0.5, this one 102.2493 plus 4.25. Divide all that by this discounting rate, 1 plus R. The R is 5.4289. 1 plus that will be equal to 1.054289, which is equal to at this point, this is equal to 98.8166. Moving on, this point we have 0.5 into 1.102.2493, this cash flow, plus 4.25 plus 4.25 plus 0.5 times 104.3931 plus 4.25. Divide all that by 4.44, 1.04448. Answer here is 102.933. That is at this point. Now we want to move to the last node. We want to move back to the last node. The last node, we're going to take these two, which is 0.5, this 0.5 into 98.816 plus 4.25 plus 0.5 into 102.9933 plus 4.25. Divide by 1.035. This will be equal to, this is going to be equal to 102.0821. And candidates, this is the answer. The last one here is the answer. That is the value of a step-up option-free bond. That is if the bond is not callable. If the bond is not callable, the value is, this is Roman 1. We are answering part C, Roman 1. This is the value of the bond. The question is, calculate the value of the step-up option-free bond. That is, if the bond is not callable, the value is, if the bond is not callable, the value is shillings 102.0821. If the bond is not callable, the value of this bond is 102 shillings 0.821 cents. Roman 2. we are to calculate the value of a step-up callable bond. The value of a step-up callable bond. Value of step-up callable bond is, that's what we need to calculate. Value of step-up callable bond. I'm going to use the same tree, but I will do away with these values. We are going to have new values. Going to have new values. So what will be the value of the callable bond? The first one was not a callable bond. It was a free bond. We're going to use the same approach, and we will demonstrate the difference as we move along. We're going to first of all add these two. 100 plus 7.5 times 0.5 plus 100 plus 7.5 times 0.5, the value we put here by using, and in so doing we're going to use this discounting rate. So we're going to have 0.5, 100 plus 7.5 plus 0.5, 100 plus 7.5 divide by 1.09, that is 1 plus R. This is a percentage. Convert it into decimal, then add 1. You will get 1.091987. Moving to the calculator, the answer here will be 98.444. Next, we have these two. We use this discounting rate to get the present value. 0.5, 100 plus 7.5 plus 0.5, 100 plus 7.5 divide by 1.075312. $99.9710. Next, we're going to have workings. Next, these two, 0.5, 100 plus 7.5 plus 0.5, 100 plus 7.5 divide 1.10, 1.06, 1660. So I get here 102.2565. Next, have 0.5, 100 plus 7.5 plus 0.5, 100 plus 7.5 divide 1.05, 1.05, 0483. It's 102.333 0.39. We are through with the year 3. We are now going to calculate year 2. Year 2. Year 2. So we're going to have these 2 plus 7.5, 0.5, it's 98.444 plus 7.5 plus 0.5 into, so it's 95, 8, 99, 99.9710 plus 7.5 divide by this 1.070053. But 99.7219. We come down here. Now I want you to be keen with this one. Now, candidates, we read from the question that this bond is callable at 100. Did we read that? The note is callable at par. The note is callable at par. You can see here, this is beyond the par value. The par value is 100. So when computing the value at this point, we will not use any values that are beyond the par value. So here we'll use 100, the par value. The same thing will apply here. We are going to use 100 when computing the value at this node. You understand? Here, the bond is callable at par. It's going to have 0.5 into this value. This is below the par value, 99.9710 plus 7.5 plus 0.5. Now at this point, we are using 100 and not the 101. This should be 101. This is 101 and not the 101. So we're going to have it at par, 100 plus 7.5 divide by 1.05, 1.05, 7354. It's equal to 101.6552. Next. At this point, we're going to have the 100, 0.5, 0.5, 0.5, 0.5. Yes, this 0.5 times 100 plus 7.5 plus 0.5. Same thing applies here. We're going to use 100 and not 102 because these bonds are called at par. So I have 100 plus 7.5 over 1.046958.9. This is a percent, not 9. 102.6784. We are done with the year 2. We move on to year 1. Year 1, we will take this times this plus 4.25. We're going to have 0.5 into 99.7219 plus 4.25 is the interest, 4.25 plus 0.5 into 100. This is above the par, so we'll use 100. Is 100 plus 4.25. We divide by 1.054289. This one. Year 1. The answer is 98.7499. Lastly, we have at this point, we need to calculate here. We'll take 100, 0.5, 100 plus 4.25 plus 0.5 into, here it will be 100, 100 plus 4.25, divide by 1.04448. I get here 99.8135. Then we are going to carry out the last operation. The last operation will add this and that times 0.5. 0.5 times 98.7499 plus 4.25 plus 0.5 times 99.8135 plus 4.25. Divide all that by 1.03, 1.035. This is 1 plus R. Our R is 3.5. Converted into decimal, we have 0.035 plus 1, we get 1.035. Which gives me, the answer here is 100.0306. That is the answer. That is the value of the step-up callable bond. Value of the step-up callable bond. The value of the step-up callable bond. The value of the step-up callable bond is shillings 100.0306 cents. So Roman 3, we have to calculate the value of the embedded call option. Now the value of the embedded call option will be the difference between the value of the callable option and the optionless note. So this will be equal to the optionless step up note minus the value of the callable bond, minus value of the callable bond. And we have these two values. This is 102.0821 minus this value of 100.036. This difference will be the value of the embedded call option, the value of the embedded call option, which is equal to shillings, 2 shillings and 461 cents. That is the value of the embedded call option is equal to the optionless step-up note minus the value of the callable bond, which is equal to 2 shillings and 0.461 cents. So, candidates, we've answered question 4. We've answered question 4. Please take time and go through the question one more time. You can see 4, and you can see the marks awarded are few because the question is easy. This question is straightforward. First part, candidates were to earn only 4 marks. This one is 4 marks. Number 2 is 4 marks. Number 3 is just 2 marks. So to calculate the value of the callable bond, you saw what we did. We worked backwards from right to left, taking into account the probabilities. Then when calculating the value of the step-up callable bond, you'll note that we read from the question that the bond is called at par. So at any point where there is the par value is more than 100, then we used 100 and not the value that contained the premium. So that's it for today's lesson. In our next session, we are going to answer question 5. The subject is fixed income analysis. If you have any questions, please feel free to ask. If there is any past paper question that you would want us to work out for you here on the board, communicate and we'll gladly do so. So that's the end of December 2023 question 4. God bless you. Bye.